Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to talk about this diode connected device for NMOS or PMOS transistors, and we're gonna look at the resistance that we can see between drain and source of this special device that use it a lot in different problems in CMOS amplifiers. But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button, and also the notification bell. So let's jump into it. This is a diode connected device. Why we call it diode connected? Because it made the transistor from three different pins to 2 pins. It is a we can model this with just a resistor, and I'm going to calculate later on this resistance that we can see. Imagine a small signal model for transistor, and this is what we use for calculating this resistance. The small signal model for NMOS is this one: plus minus VGS, GM VGS, which is GM is a transconductance, and just for the sake of simplicity, neglect the channel length modulation. Okay, this is source, this is gate, and this one is drain. And as you all know, VGS is is just a variable in this model, and GM is a constant, which is called transconductance of this amplifier. So now I'm going to calculate the resistance from these nodes between drain and source. This means that I'm going to put some voltage source, we call it Vx, and the drain, the current through it is Ix, and I'm going to calculate Vx divided by Ix in order to calculate the resistance through these nodes. Okay, and if you look at it carefully, you can see there is a short circuit between gate and drain of this transistor. So I'm gonna use this short circuit to calculate my resistance. This is the short circuit. You see, gate to drain. I short circuit gate to drain of this model. Now, as you see, by short circuiting this, I can simplify this circuit. We have a dependent current source depend to the voltage, and here it's voltage. You can always model the current dependent to its own voltage with a resistor. And what is the value of resistor? The voltage divided by current. So simply. So I can simplify this with this one. What is its voltage? Its voltage is VGS. What is its current? Its current is GM VGS. So I can simplify this one, and I can get the result 1 divided by GM. And this is all we have left. We have no additional resistor. So Vx divided by Ix is just 1 divided by GM. And if we are to consider the channel length modulation, as you all know, we have a RO or R drain source resistance between drain and source, and this resistance is just simply parallel with this 1 divided by GM, RDS. But in most cases, this resistance is much higher than 1 divided by GM, so most of the time this RAX is just approximately equals to 1 divided by GM. This is the device that we call diode connected devices, and most of the times in CMOS amplifiers we just can remove it and put this resistance instead of it. For example, just look at this amplifier. This is an amplifier. This is a common source amplifier, and with its load is this diode connected device. This is M1, this is M2. I just simply can use this circuit as a model. I just remove this resistance, this transistor, and put this resistance instead of it. The value of it 1 divided by GM subscript 2, because this is for M2 transistor, and with that you can simply calculate, for example, the voltage gain of this amplifier or the output resistance, whatever you want. This is so simply, and try to commit this to your memory. You can always model the dependent current of its own voltage with this one, or vice versa, the dependent voltage of its own current. You can model this with the resistance, and the value of resistance is just the voltage divided by current. So that's it for this video. I hope you like it. If that's the case, please give me a thumbs up and share this video with your friend. Thanks for watching.